Hi, my name is Dana Golden. Today we're going to be continuing with uh, our Intro to Data Science and Machine Learning with optimization. So let's start off with gradient descent. So remember, gradient descent is reducing by the gradient each time times the learning rate. And we take the gradient equals, take the derivative of this, 2 times x plus 4. X equals 10, learning rate, and then we try and find the minimum of this function, the x that minimizes this function. So if you remember from calculus, we can just set 4 equals negative 4 equals 2x, which gets very close to negative 2. Actually is negative 2, but negative 4 equals 2x, which is negative 2. So we're optimizing this numerically rather than analytically. So x minus the learning rate times the grad. So if you notice at the start, we go from 7.6. We have a high gradient, and then as we decrease, we get a lower and lower gradient until we're almost at negative 2. We have a numerical issue, and so the gradient is effectively 0, and also the function is effectively 0. And then Newton's method is very similar, except now we're adding in the second derivative as a way to find the learning rate. So for I in range 100, Newton's equals gradient of x divided by second derivative of x. So we're decreasing the learning rate as time goes on. So we start off with a higher learning rate, and we go on with a lower learning rate. So we're going to minimize this objective. So this gets you there a lot faster, and it moves a lot quicker. Let's actually start out back with x equals 10. So yeah, as starts off moving a lot faster because the second derivative is larger, and then it goes slower over time. And then we can also do minimize from SciPy, which we minimize the objective function, which we set out here objective of x. And then we could do this with actually any function. So we could start off with x cubed, and then also get the minimum from there using SciPy. And then we get data equals load breast cancer, data equals data equals data target. We plot the data. Here is the mean texture. Here's the mean radius. So this is a data set trying to classify tumors as malign or malignant or benign. So as you can see, there's some overlap here. Over here, they're mostly malignant. Over here, they're mostly benign. So we split up into train and test. We standardize the features, set up a parameter grid, and then we do grid search with cross-validation, and we find the best models. So this is an example of optimization with SciPy. Then we're going to do the same thing with Torch. Now we have a regression. We create a basic linear model, and we're going to have a mean squared loss, and we're going to optimize it. So over time, we're going to step in the direction of the gradient, and we're going to decrease until our values are close to 0. Here's linear regression using PyTorch optimization. So we get a really nice fit that looks about right. And then you can also minimize using SciPy with constraints. So now we've decided that x is between 0.5 and 1. So we don't allow it to go fully to 0. We'll find the optimum with these settled constraints. X0, and then the constraint is that x0 plus x1 minus 1 is equal to 0. So your constraint, you're setting something equal to 0, minus 2. So this is nice. This is like what you do a lot in economics. This is what Lagrangian optimization really is you're finding the minimum or maximum of a function with constraints. So here's global optimization. Now you have no constraints. You're finding the optimal parameters without any constraints, but with bounds on your initial parameters. And here, this is another example of optimization, kind of with game theory, showing you how you can use optimization to basically solve a linear program that solves rock, paper, scissors. I'm not going to go through running this code because I don't have the correct package imported in this code. But basically you have R equals the beginning plays, and then you solve it here. So you have constraints, you have an objective, you have a problem, and then you solve. And then you get your strategy matrix, and when you end up with this, you get 0.333, 0.333, 0.333. So this is a program that solves rock, paper, scissors with linear programming. So that's an example of how you can use game theory with linear programming in Python.